last talk in our series of 5. Let me get this going here. Okay, we've had a series of 5 talks on the steps of publishing your data with EDI, and this is the last stage of that list of 5, which is to cite and link. And so we're going to show you first a simple catalog, which I'll illustrate, and then Dwayne is going to talk about actually querying the repository and some of the tools that you need to create your own catalog. So this, I'm going to show you first how to do this simple catalog. This is basically for those of you who have only a few data sets and you have a page on an existing website where you want to highlight them. So this is an example of another project that I work with, which is a biodiversity observation network in the Santa Barbara Channel. You should be able to see their URL there, but we'll have these talks online, so you'll be able to get it later. This group is expecting about 15 data packages altogether, so they really don't need complex search functions. They can list all their data sets on one page, and they can group them with HTML. So in my experience, a one-page list is fine if you only have up to about 20 data sets. It's relatively straightforward for you to group them in HTML lists or tables, and it's relatively straightforward for a visitor to scan them. But if you have more than about 20, it starts to get confusing. So what this group did here was to put a text description. I think I have a pointer here somewhere, right? How do I find a pointer? Oh, there. They put a text description here of a group of data sets and used a hyperlink over here just to point to the data set in the repository. So their title, and then they included the titles over here. This is the anchor tag is about the simplest thing you can do on a website. And so I'll show you what those tags look like. This is an example of that link right out of their HTML. And so you're pointing to the data set using its identifier here. And of course, you can use any text you like as the anchor. You can even use the link itself if you want. But here they kept the data set titles in a separate table cell so that the actual link could be kept short and they'd all stay a nice even width. And you recall that EDI supports dataset revisions, so it's important that your link points to the newest revision of the dataset. So even if you update that dataset, and say it's a time series and you want to put in new records each year, you will not have to update the web page. And so these are the components of the link that you would need to use, that you have to be aware of. The scope. This is most of the data sets that are the basic EDI. Well, you'll know what your scope is. And the identifier you were assigned when you put the data set in, and this is key, this word newest here on the end. You could use a revision like 1. You could use a number 1, 2, or 3, but then you'd be updating this link all the time. If you use newest, the repository code will find the revisions, the highest revision number, and return that. And so these are a group of pages that belong to the research organizations that we've already worked with, and on all these pages you could very easily add a link to highlight that, to point right to the data sets in the repository. For myself, I like to see data sets in lists or table cells rather than in a paragraph text, but of course that's up to you. So a couple more things about links that you should know. There's another way to create a link to this data set. Because the repository, because of the repository assigns DOIs, you could actually use a link that points to a specific revision with a DOI resolver at the head. This will go directly to a specific revision. So the first part of that is this DOI resolver here, and then the DOI of the data set, which you can get from the citation. So this is an alternative approach to the one I showed you before. But you might want to choose which type of a link to use. If you're citing a data set, for example, in a paper, you should use the DOI because it's permanent. And it's the responsibility of someone assigning a DOI to keep it viable. But that DOI will go to a specific revision. So that's perfect for a citation. You want it to go to a specific revision. But for a general catalog on a website, you will probably want to always point to the newest revision of the data set. So that way, so there you would use the repository ID with the newest parameter setting at the end. And so now when the user reaches the dataset landing page, he or she would see the citation with the DOI in it, and they'll be able to cite it correctly. So this is all I have for now because it's relatively straightforward to use that, that simple link to create a small catalog. But Dwayne has lots more to tell you about the more complex aspects of building a catalog and how to actually write queries. So I'm going to get out of presentation mode, and Dwayne, hand it over to you. Oh, do I have to unshare? Perhaps I have to unshare. Stop.
Okay. I'm looking for my share screen. Okay. Here we go, I think. All right, can everyone see that?
Yes.
All right. Okay, thanks, Margaret and Suzanne. Last summer, I presented an EDI online tutorial that covered the Pasta Plus Search API. If you happen to have attended that webinar or watched that video, you'll notice that today's presentation will overlap with much of what was covered in that previous tutorial. But today, I'll try to place more emphasis on how to use the Pasta Plus Search API for the specific purpose of creating a local data catalog. What are some of the possible motivations for learning and using the Pasta Plus Search API to create a local data catalog? First, we could use the Search API to build a static local catalog listing or inventory. In this case, our program is not accepting query input from an end user, but we're constructing the entire Pasta Plus query ourselves and displaying a table of matching documents for our local site or project. In that table, we display things like the document's DOI, title, authors, keywords, and perhaps the abstract, and links to the full metadata and data objects. Our search query is a filter that matches all the metadata from the central data repository that is pertinent to our site or project, filtering out everything else that isn't. You might think of this query as a fish net designed to catch all the fish that belong to our site or project while leaving everything else behind in the ocean. Later, we'll look at some examples of how to accomplish this. Second, as part of that local data catalog, we may want to support a search interface for our end users. This may range in complexity from a simple search box that allows users to input one or more query terms, or we may want to build a highly customized search interface that supports some feature or behavior not found in the central EDI data portal. For example, we may want to build a search interface that suggests a number of keywords commonly used at our site or project and let the user select them from, say, a list box, or perhaps browse the terms organized in a tree hierarchy. There are several advantages to using Pasta Plus's Search API to build a local data catalog, such as the fact that the contents of the local data catalog will always be synchronized with the contents of the central repository. That is, you needn't bother to maintain a separate listing for your local inventory. You instead let Pasta Plus generate that listing for you based on consistent filtering criteria. This is less error-prone as well as easier to maintain because it automates much of the workflow. Finally, it should be pointed out that using the Pasta Plus API does not preclude the use of local design choices. You can use the Pasta Plus Search API under the hood, so to speak, while still retaining local styling and branding in the view you present to end users. As alluded to above, there's tremendous flexibility in how you want to use the Pasta Plus Search API to best advantage. But this also means that there are a number of different design and implementation decisions you'll need to make. There's really no single best choice for any of these. It depends on what technologies are already being used at your site, what you and your coworkers are most adept with, and how much time and effort you have to invest in building and maintaining the data catalog. I'll return to this topic later, but for right now, I think it's important to get into the details of what all these solutions have in common, use of the Pasta Plus Search API. Regardless of which design and implementation approach you choose, you'll need to know a fair amount about how to construct a query that uses the Pasta Plus Search API, at a minimum, you'll need a query that constructs that fishnet referred to earlier, the one that filters on all the data packages in your local data catalog. So let's look at how to accomplish this. The Pasta Plus Search API is built on a technology called SOLR, which in turn is built on Apache Lucene search engine technology. Very thick books have been written about both SOLR and Lucene. Suffice it to say that they are amazing technologies. I won't be able to cover them in depth, but I think that by the end of this presentation, you'll have a good appreciation for what they can accomplish and how they're used by Pasta Plus. In this highly technical diagram, we see the high-level view of a client program sending a request to Pasta Plus via its REST API. Pasta Plus processes the request and sends a response back to the client. I include this here simply to point out that the Pasta Plus Search API is really just another web service provided by Pasta Plus, one of over 50 total, though an important one because of the richness of information it can return and at blazingly fast speeds. Looking at the web service topology in a bit more detail, we see that the centralized EDI data portal calls exactly the same Pasta Plus Search API that we'll be covering in this presentation. In other words, there's nothing inherently different or unique about the data portal search interface that can't be replicated in your own client program. In both cases, the client uses a web service URL that makes a GET request, interacting first with the gatekeeper component of Pasta Plus, which then interacts with the data package component, which in turn interacts with the SOLR server. The search results are generated by SOLR and sent back along the same route in reverse, arriving in the HTTP response body as XML. It's not all that important to understand the individual steps in this process. The main point being that whether it's the centralized data portal or your script or program or content management system or browser or curl command, they all interact with Pasta Plus using the same web service API. To understand the Pasta Plus Search API, I think it helps to break it down into 3 steps. First, we need to know what metadata fields are searchable in Pasta Plus, because we can't begin to construct good queries unless we know the names of the things that are queryable. Second, we'll need to know how to compose a query and send it to Pasta Plus. And third, we'll need to know what we're getting back as search results from Pasta Plus and how to interpret it. With regard to indexing, it's important to point out that not all metadata fields documented in EML are indexed by Pasta Plus in SOLR. For example, date-time attributes in EML are accompanied by format string elements to document the format of temporal data. The current thinking is that there are no viable use cases where an end user would want to search EML metadata based on the particular format string specified for date-time attributes, such as YYYY-MM-DD. And so this field is not currently indexed in SOLR. Let's look at the queryable fields that Pasta Plus does store in SOLR. These are the bits and chunks of metadata that Pasta Plus has extracted from the EML documents in its repository and indexed in SOLR so that SOLR can perform its searches based on the criteria we send to it and then return search results to us quickly and efficiently and ranked by their relevance to our search criteria. The fields include a variety of different identifier values such as the DOI, Digital Object Identifier, many string and text fields, as well as fields involving temporal and spatial criteria. I'll be demonstrating a few examples to show how these fields come into play when composing our queries and in the XML search results that Pasta Plus sends back to us in its response. Now that we know which fields can be queried, let's look at how to compose those queries. The formal documentation for the Pasta Plus Search API looks simple enough. Using the HTTP GET method, retrieve the results from searching Pasta Plus's EML data packages. But the richness of this web service is the portion that comes after the question mark, the query parameters. We'll explore this further with a couple of examples. In our first example, we compose a query string using only 2 query parameters in our URL. The Q parameter says, here's the field and the text I want you to match. Keyword is the name of the indexed field that is being queried, and we want to match all documents that have the word disturbance as the value of at least one keyword. The second parameter, FL, specifies the field list we are asking Pasta Plus to return. In this case, we're saying that for each matching document, all we want to know is its ID value, such as edi.1. This is pretty simple, right? Only 2 query parameters. This URL is something you could type into a browser and you would see the results return almost immediately. In this second example, we see a URL with 7 separate query parameters separated by ampersands. Although much longer than the previous example, this query is probably more typical of the kind used to build a local data catalog. It looks a bit intimidating at first, but we'll break it down one step at a time. The first thing to note is that I've structured this example as a curl command that can be executed in a command shell such as Bash or Linux, or an MS-DOS command window on Windows. Curl is a handy utility that makes it easy to test client-side calls to web services such as the Pasta Plus Search API. We're asking curl to run the get HTTP action, and we pass in the URL. Normally, the entire curl command, including the very long URL and quotes, should all be on the same line. The entire URL has to be surrounded by double quotes to prevent the command shell from interpreting the ampersands within the URL as special characters to the shell, and this is true on both Linux and Windows. The quotes aren't always necessary, but in this example they are because of the command shell environment. The first query parameter, Q equals keyword : fish, indicates that we want to match the string fish in the keyword metadata field. This might have originated as input that the user entered in a search box for the cases where our local data catalog is more than a simple listing and also supports a search interface. The second query parameter is a bit long. FQ equals title : %22 north plus inlet plus LTR %22. The FQ filter query parameter is very much like the Q query parameter, but with one difference. We use the Q parameter for constructing our main query, and SOLR also uses those query terms when it calculates a relevance score for each matching document. We use the FQ parameter when we need to apply additional filtering to our query results, but the filtering terms do not factor into relevance scoring calculations. In this example, we want to filter our results on the search phrase North Inlet LTER as a single search phrase surrounded by quotes, not as 3 separate words. It must be found specifically in the title field, and it won't apply toward relevant scoring. Note the URL encoded characters around North Inlet LTER, as well as the plus signs between the 3 words. %22 is the URL encoding for double quotes, which was necessary here because we already have a pair of literal double quotes surrounding the URL. Next, the plus sign is used within URLs to represent a space character, or you might also see %20, which represents the same thing. The third query parameter, FL equals DOI, package ID, etc., specifies the list of fields that we are asking to have returned for each matching document. If we aren't being choosy about which fields to return in the search results, we could say FL equals asterisk, which means return all the fields that Pasta Plus has indexed for each of the matching documents. Note that the score field, unlike the other fields in the list, is not metadata that Pasta Plus has indexed in SOLR, but it's the relevance score, a floating point value that SOLR dynamically calculates for each document based on how strong a match the document was to our search criteria. The higher the score, the stronger the match. The fourth query parameter, sort equals score, DESC, asks that search results be sorted by score in descending order. And this makes sense in most search interfaces where you'd of course want to display the most relevant matches ahead of less relevant matches. In the case of ties, we have a secondary sort in our fifth query parameter, sort equals package ID, comma ASC, this time based on package IDs in ascending order. The final two query parameters, start equals 0 and rows equals 10, asks for SOLR to return 10 rows starting at index 0. If we were implementing a web application that pages through its search results 10 documents at a time, we would display the first 10 documents to the user, and if more than 10 documents were matched and the user were to select the next button, we would rerun this query, but this time specifying start equals 10 and rows equals 10 for page 2, and then start equals 20 and rows equals 10 for page 3, and so forth. This is, in fact, exactly how the EDI data portal behaves. If you omit the start in rows parameters, start equals 0 and rows equals 10 are the default values, so that is what you'll get back every time you rerun the query. On the other hand, if you're not concerned with paging and you just want to grab all the documents belonging to your local data catalog in one fell swoop for subsequent processing by your program, you can specify a rows value that you know a priori is higher than the total number of data packages in your inventory. For example, if I expect to match 120 documents, I might specify start equals 0 and rows equals 300, which assures me that I'll get everything at one time. Congratulations, if you managed to stick with it through this entire example, you are now becoming quite the PASTA Plus query expert. Before we move on, however, I'd like to spend a little more time on the use of the Q and FQ parameters, because this is where we'll be constructing our fishnet that catches all the data packages for our local catalog while leaving the rest behind. Just to reiterate, we use the Q parameter to provide search criteria for SOLR to query on in the documents that are matched or assigned a relevance score. But in this use case, creating a local inventory of documents, we're not interested in relevance scoring. We only want to know whether a document gets trapped in our net or not. So I think it works well to let Q match everything by using Q equals asterisk, a wildcard query that will match any content in any field of any document in the repository, but then use the FQ parameter to do the actual heavy lifting of including all the documents that belong in our inventory. The first example above is very simple. Filter on scope value of KNB-LTER-HBR. As Margaret mentioned, package identifiers in PASTA Plus use the format scope.identifier.revision. The scope is a sort of namespace that collects a group of related data packages, and we index the scope value of each EML document for purposes of search. Historically, each LTER site has been assigned a dedicated scope value in the standard format KNB-LTER-XYZ, where XYZ is the three-letter site abbreviation in lowercase. This example uses the scope value for the Hubbard Brook LTER. This makes it easy to match all data packages from a particular LTER site. Simply filter on that site's scope value. However, the dedicated scope value per site scheme has some inherent limitations. More recently, as EDI supports a broader range of communities, we're moving away from that approach. Many of the newer data packages other than LTER are collected under a more general EDI scope. In these cases, how can we match a group of data packages from a particular site or project? To accomplish this, and at the risk of mixing my nautical metaphors, we need to place a hook in the metadata, something in the metadata that's searchable, that's found in all of the data packages we're interested in, and not found in any others. I looked at some of the data packages under the EDI scope in the PASTA Plus repository and found what I think are some good examples that meet these criteria. In the second example, we use a wildcard query, and we filter our search on scope EDI, and then we add a second filter query on the text Illinois EPA Ambient Lake Monitoring Program, ALMP, in the title to isolate all of the documents originating from that program. In the third example, once again, we filter on scope EDI, and this time we add a second filter query on the project title element instead of the title element, filtering on the boilerplate text, the University of Kansas Field Station, Kansas, USA. The final example uses a grant number in the text of the funding element as a way to collect together all data packages funded by a particular grant. It's important to place the filter value within quotes to ensure an exact match to that grant number. Otherwise, SOLR will include close matches to that grant number in our query results, which we probably don't want. Finally, it makes sense to plan for this in advance. That is, design your metadata text in a way that ensures that the hook, the snippet of metadata text that can be reliably filtered on, will be something common to all of the documents in your inventory and no one else's. For anyone interested in doing this, I think it's a good topic of discussion to take up with EDI's team of metadata experts, Colin, Corinna, Kristen, and Margaret. The third key to understanding the PASTA+ Search API is to understand how the search results are structured. PASTA+ returns the results as XML. The XML document shown here may look at first glance like an EML document because so many of the field names are similar, but it's not. This is the result set XML returned by the PASTA+ Search API. In this example, we've run a query that effectively says, give me all the fields you've indexed for the matching documents, which in this case is guaranteed to be a single document, the one with package ID of knb-lter-nin.1.1 from the North Inlet LTER. The top level result set element shows that one document was matched in its num_found attribute, as we expected. Within that result set element is a single document element, and within that document element are all of the individual fields that PASTA+ has indexed in SOLR for this document. I think most of the element names are self-explanatory, DOI, abstract, for example, but note that we have some temporal coverage fields, begin date, end date, and pub date, the publication date. Viewing the remainder of the search results XML, we can also see spatial coverage containing one or more bounding box coordinates. We see individual keyword elements wrapped by an outer keywords element. There are also a few empty fields visible in these results, for example, taxonomic, single dates, and timescales. These are cases where these metadata fields were not provided in the original EML metadata, so there were no values that could be indexed. Finally, in the last two lines of the XML, we see the closing tags for the single document that was matched and then for the entire result set element. Working with these search results is a matter of parsing out the fields that you're interested in from the XML. For example, when displaying your local data catalog or a subset of it based on a user query, you might want to include the title, abstract authors, and keywords, perhaps the DOI or the package ID. So those are the fields your script or program or XSLT style sheet would need to parse out of this XML, ignoring the rest. At this point, we've covered all three of the topics for understanding the PASTA+ Search API. What fields can be queried? How do we compose a query, especially with regard to constructing a data catalog? And how is the XML that PASTA+ sends back to us structured? Armed with this knowledge, you should be able to begin to incorporate the PASTA+ Search API into your particular solution for building a local data catalog. But of course, it may involve some experimentation, which is fine. I think there's time, so I'd like to go into a bit more depth on the topic of design and implementation choices. First, with regard to the user interface, is it a simple listing of all the inventory in your data catalog, or does it allow the user to input and run a search query? If the latter, is it a simple search on one or more query terms, or perhaps a controlled vocabulary of keywords organized as a list or a browse tree? In my example query, I'm envisioning a website for the Maria Coral Reef LTER that offers a search interface on keywords that are meaningful at MCR, one of them being Pusillipora. We ask the PASTA+ Search Web Service to match all documents with keyword Pusillipora, and filter the results on the scope value knb-lter-mcr. When I ran this query, 4 documents were matched. Which programming language or content management system will be interacting with Pasta Plus web services? There are lots of choices here because virtually all modern programming languages and CMSs offer a means to make HTTP web service requests. The EDI data portal uses Java, but EDI developers are also using Python for many scripting and programming tasks, while others have successfully implemented solutions in R, PHP, and JavaScript. JavaScript is a particularly interesting choice because it can run entirely in the web browser, interacting directly with Pasta Plus without the intervention of a back-end web server. Tim Whitaker, who's with us here today from the Beaufort Lagoon Ecosystems LTER, recently developed a JavaScript solution which he has made available on GitHub. It requires that Pasta Plus web services support something called CORS, cross-origin resource sharing. At Tim's urging, Pasta Plus now supports CORS as of last week, and there'll be a bit more to say about this later. When you get your query results back from Pasta Plus in the form of XML, you'll need to decide how to parse it and transform it to human-readable HTML. XSLT is made for doing this type of transformation, but many people find it difficult to work with. Others have used programmatic solutions in Python, R, and Java because these languages all have powerful XML parsers available to them. I find myself going in that direction more and more because honestly, I can't call myself a big fan of XSLT. Your local data catalog will contain links to the metadata documents and related data objects. Margaret demonstrated a couple of ways to compose these. One way is to use the DOI. A quick and relatively easy way to do this in conjunction with using the Pasta Plus Search API is to include the DOI in the field list of your search results. Then take that part, the part that begins with 10.6073, this is the DOI shoulder for all Pasta Plus documents, and then prepend https://doi.org. Now you have a link to the DOI landing page for that document, which resolves to the central data portal. If you prefer that end users not leave your local data catalog website, but you still want to let the central data catalog display the document, you can place this link inside an HTML iframe element, which displays a web page within a web page. If you prefer to avoid linking to the central data catalog altogether, you'll need to access the full EML metadata document from Pasta Plus using a separate web service called read metadata, parse the EML XML that it returns, and construct your own web page for the data package that you link to from your data catalog. This is a lot more work, but it gives you full control over how the metadata is displayed in terms of its organization, styling, and branding. In addition to the information provided today, there is also a presentation that was given at ESIP 2017 by myself and 3 colleagues, all of them LTER information managers, with the title, Use Application Programming Interfaces of Data Repositories to Create Local Data Catalogs. I think you'll find it very informative because it tackles the topic of creating a local data catalog from several different perspectives and offers a number of potential solutions. One of the things we've tried to emphasize today is that there's no one correct way to go about this. We can only offer suggestions and point you in some promising directions. My co-presenters for the ESIP presentation, Stephen Earle, Gastel Beal, and John Porter, presented a number of actual use cases and examples of how they and others construct web forms to query Pasta Plus using its search API, and how the search results that are returned can be processed, rendered as HTML, and combined with your site's particular styling and branding to produce an attractive local data catalog for end users. Online videos of both the Pasta Plus Search API tutorial from last summer that I mentioned at the start of my talk, as well as the ESIP 2017 presentation on local data catalogs, are easy to find and access from the EDI website under Resources EDI on YouTube, and then by selecting the videos menu item on EDI's YouTube page to see the full catalog of EDI YouTube videos. When I last checked, there were a dozen or so videos currently available, and today's presentation will soon be added to that list. Here are additional resources with links and contact info. The last link in the list is Tim Whitaker's JavaScript-based data catalog solution that I mentioned earlier. Fortunately, we'll be hearing from Tim in an upcoming EDI webinar currently scheduled, I think, for May 29th. I'm really looking forward to hearing Tim describe his JavaScript solution in greater detail, and I hope you'll join us for that one. Thank you and happy searching, and hopefully we have some time left for Q&A and discussion.
Thank you, Dwayne and Margaret, for the interesting presentation. And Tim has a question.
Yes, I was wondering if I want to sort by a particular field, do I have to include that field in the FL query parameter?
I think it need not be included, so you can sort on that field without actually including it in your XML search results. I'm pretty sure I've done that.
I'll also say that the link that you posted to that JavaScript client is for a pure SOLR solution. It's written for the Arctic Data Center, but there is one for Pasta as well in my GitHub repository.
Okay, and so I think we'll be getting that in a few weeks, right? As part of your presentation. Excellent.
Yep.
Any other questions or topics to discuss? Do we have anyone who's thinking about attempting this in the near future? Oh, good, great, Hap. Excellent.
So yeah, I've got just a question on the, in the beginning of your presentation, you were talking about the indexing of the certain fields or parameters that you could query on, I guess, right?
Mm-hmm.
So, but that's not all, you said it's not all of the EML fields that are there. So how is that determined, and would other fields potentially be able to be added to that?
Okay, good question. It's a judgment call, and we think to ourselves, for this particular field in EML, is that a searchable field? Would anybody actually want to search on a datetime format string, for example? Or let's take like an attribute name. If would somebody actually search on MM for millimeters and end up matching MM in months, for year, month, date? So some fields just would cause too many false positives, and others are just things that they're part of the metadata, but they're not really searchable aspects of the document. But the second part of your question, could new fields be added? The answer is yes. If somebody said you really should start indexing attribute labels, then make the case for it. It doesn't even have to be a strong case. Then we could start doing that. And what it requires is that we do a little update to our configuration for SOLR. We say this is now a searchable field, and then we have to re-index all 42,000 plus EML metadata documents, and that's about a 10 to 12 hour overnight operation, but it's still something that can be easily done. So let us know if you do come across something that's not currently indexed that you think ought to be. Margaret?
I'm going to ask a question about, this might be more general SOLR, so you're free to tell me to go look it up myself. I'm just curious about constructing more complex queries. Suppose I wanted to put an AND. Is the construct relatively straightforward to figure out, like where the brackets go, or
yeah.
I want things with this fish. I mean, I want a fish and I want a creator or something together in the same set.
The actual query terms, like the Q colon, Q equals keyword colon, and then everything that comes after the equal sign. I don't know, sure I stated that correctly. Q equals keyword colon, yeah, and then the thing you're actually searching on. It can get more complex, and it can include ands and parentheses, and there are probably some good, if you just Googled SOLR queries, you'd find better examples. I didn't feel like I had time to go into a really complex example, but the anding and the oring, all of that is possible. Or maybe you could drop me a line and we'll work on it together.
Well, I was thinking, in not just you and I, that there might be like LTER sites who would want to be able to, that there's probably a relatively small number of these kinds of things to do, you know, keyword and creator or place and create or something like that, that maybe it's worth it for, if we can assemble a list of those kinds of things, we could come up with a set of examples or a primer or something. I mean, I always find it easier to work from examples for a lot of these kind of activities.
Right. And yeah, the data portal uses those kind of more complex queries, and especially in its advanced search form, because it has to connect a whole bunch of different searches criteria together. And I find myself having to always kind of relearn that syntax and experiment to make sure that I've got it right. So, but it is doable.
So actually, I had a question for this group. And then several people raised their hands when, you know, and I assume you're here because you're thinking about writing a catalog. It seems like one of the ways that we could collaborate would be to figure out who's planning to use certain kinds of technology. I mean, who writes in Python, who writes in JavaScript, and whether there are sharing opportunities there so that we don't all end up reproducing each other's work. If anybody's interested in that sort of thing, we could possibly we can set up an ASM session or something. I'm not quite sure the best way to move forward, but it'd be good to know who's interested in that kind of collaboration first. So feel free to chime in right now if you like.
I think that's a great idea.
I think some of us are at the point where we actually are looking for a new solution, and if it turns out that someone's written the whole thing in Python, gosh, we'll probably want to go with Python, but we don't know that yet. So that's kind of where we are. Or JavaScript.
Sorry, I was going to say, you haven't seen Tim's solution yet.
Right.
Preferable one.
At FCE, we've been toying with the PHP solution that John Porter created. He's mentioned it in the group chat here.
So maybe it'd be nice to have a list of these, or at least what we have partial solutions for, and who's got bits and pieces. I still have lots of style sheets, that XSL style sheets that can process a whole XML, a whole EML document, but they need a little updating. Anyway, there's things like that. We know that there's bits and pieces out there, but gathering them all up would take us a little bit of time.
Ironically, or maybe coincidentally, I happen to be using FCE as the test case for my Pasta JavaScript client because BLE doesn't have any data yet. So if you'd like to see what that looks like, it's actually live on something called Rawgit, and I pasted a link in the chat window. So if you want to query FCE data, you can go hit that up right now.
I can't see it yet in the chat window.
I'm not seeing it in the chat window. Did you do it to everybody?
No, I did it to Steve Earle privately. So Steve, here we go.
Cool.
That's great, Tim. I wanted to also follow up on this idea of sites outside of LTER that would need to place some kind of hook or plant some kind of seed in their metadata, something that could be reliably searched on. Do you think I hit on the right examples of you could place something, some boilerplate text in the title, the project title, or search on the funding grant number? Can we think of any others off the top of our heads that would it be a keyword perhaps?
So a keyword actually is a reasonable choice, although I think if we were going to encourage people to use keywords, we might actually also want to use specific vocabularies. And so that would mean first that POS would have to index. I don't think it indexes the thesaurus at this point. Plus we'd have to know how to write and queries with and in them so that you could get a keyword out of a particular vocabulary to be able to have a really precise search. Some of us have already used Project, and mainly Project for when we're trying to cross query with other catalogs, other repositories. So, and we found that it works pretty well, but there is the risk that you won't use the controlled text in another data set. That always is potential could happen. So having a system that controls how you put your metadata together really helps, so that text that needs to be controlled is boilerplate.